So last class you guys learned how to condense and expand logarithms using three different properties: the power property, the product property, and the quotient property. So what you're going to be doing today is you're going to solve logs like we did a couple classes ago, but you're going to have to use the properties first to be able to solve these. So because you guys already know how to solve logs, I'm just going to jump right into example so that you guys can start learning this. Alright, if you guys remember correctly, we have two different types of solving log problems. We have the problems where they're set equal to logs on both sides, and as long as you have the same base, you drop the logs and then solve normally. The other one is where you guys have to rewrite it as an exponential. This one, as you see, does not have a log on both sides. So we're going to eventually have to rewrite this as an exponential. But the issue is that this is not a single log like it did in our previous problems. It actually has a minus sign and has two different logs. But we can use the quotient property to actually simplify this into one log. So the quotient property says that if you're subtracting two logs, you can write it as a division. So we would write log of 8, we're basically condensing, and we're going to take this part, the x plus 8, and divide it by the 7, since that is the second part. And then of course this is also equal to 1. Alright, now I can rewrite it as an exponential. So now we're back to the problems that we did a couple of classes ago. So we start with the 8, rewrite it to the first power, and equal to the x plus 8 over 7. So it's 8 to the first power equals x plus 8 all over 7. Alright, well 8 to the first power is just 8, so I really don't need that 1 there. Alright, so to help this a little bit better, I'm going to go ahead and rewrite the 8 as 8 over 1, just so that you can see that we have two fractions set equal to each other. You can cross multiply in this manner, or you can multiply both sides by 7. Essentially what you'll end up with is x plus 8 equals 8 times 7, which is 56. Alright, subtract the 8 for both sides. So you get x equals 48, which is therefore your answer. Alright, on this one. This one again is set equal to a 1. Okay, so it does not have logs on both sides of the equation. But I am going to have to condense just like I did on the other example. But with the plus sign, we use the product property. The product property says that if I have two logs that are being added together with the same base, then I can write them as 10 times the 4x. Oh, well, 10 times 4x is pretty easy because that is just 10 times 4, which is 40x. Alright, we have to rewrite this as an exponential, just like we did on the last problem. So we have 8 to the first power equals 40 times x. We don't really need the x to the first power in this case because x to the first power is 8. And then we solve it by dividing both sides by 40. So we get x equals 8 over 40, and we reduce the fraction. So I think 4 goes into both of those. Actually, 8 goes into both of those. 8 goes into 8 once. 8 goes into 40 5 times. So my answer is 1/5.